and thanks for being here to talk about how we can automate your workstation installation. First, let me introduce myself. I'm SYLVAIN METAYER, a French speaker located in Bordeaux, and I'm working at OnePoint, an IT consulting firm, and as a tech lead. As a side note, this is the first time that I'm doing an English version of this talk and my first English talk ever, so I hope your ears will get through this. My day-to-day tasks involves automation on various systems, ensuring deployments goes smoothly for developers and to assist them to push their code to production with less frictions and effort as possible. As I was automating some tasks for some of my work, I decided to give it a try and do it on my own computer as well. To do so, I had some criteria for choosing a solution, so I made the table you can see here to know if it fits my needs. First, I want to be able to manage my configuration files, also called .files, to keep the configuration of my installed softwares or my custom bash prompt. We'll talk about it later. Next, I also want to be able to manage my installed softwares because I don't want to have to remember what's installed on my machine when I do a fresh install. And I want to be able to start working with my usual tool immediately. I also want to keep track of changes to my configuration, and as you would do with your code, so I need something that I can version control. I also don't want to spend hours to configure something to configure my computer in the end, so I can work. That's why I'm looking for something that's easy to maintain. I'm also working on multiple computers, and I have to take that as a requirement too, since I share some configuration between my personal and professional laptop. I don't want to have to start over or duplicate everything. Finally, like everyone in this room, I have various secrets, SSH keys, passwords. I want a safe way to backup these without exposing these to the world. First, we'll start by seeing what .files are, then we'll see a few options to manage these, and the one I've chosen. So .files are text files containing the configuration of your softwares. This can be your Git configuration, your SSH host. These files are usually stored in your home directory and start with a dot, which explains the .files name. Here you can see an example of a bash RC that exports a custom environment variable. You probably already have multiple .files on your computer for your VM configuration or your Kubernetes config file. Now that we've seen what .files are, we'll see how to store them to ensure you can quickly recover if your computer suddenly dies. There is an unofficial website where various ways to manage these .files exist, and there is also an awesome repository here which lists other ways. Right now we'll see a few options and the one I've chosen. One of the first possible solutions to manage our .file is stow. It is a Linux tool that does one thing, and as per the Unix philosophy, it does this thing well. Stow will take a folder with a tree of files and will replicate it in your home directory with symlink. This means you can store all your configuration in a dedicated repository, version control this folder with Git, and with one command, it will sync your .files on your computer. The advantage is that it is easy to set up and quite easy to maintain thanks to the symlinks it will create on your file tree. However, if we take a look at my requirements, we can see that it will only manage my .files, and I will have to find another solution to manage my installed softwares. If you have many computers and you share some configuration between, you may need to run multiple commands, have a shared command configuration folder, or something like that. And finally, if you have secrets, you'll need to use another tool to handle store these secrets, such as Age or PGP, and encrypt, decrypt them before being able to use them. Let's move on to the next solution. Since the majority of us here are developers, grab your favorite language and let's build your own tool. I think I'm missing something. This morning, I remember this was a Java conference, so I added the Java mascot right here, so no one would feel offended if it was missing. Now we can continue. The main advantage is that you can do everything you want with your favorite language. In your case, I guess that's Java. You'll be able to check all these requirements and even more. You're the one in charge from the beginning to the end of your project. However, how much time will you spend to configure this tool to fit every one of your needs? You will need to ensure that upgrade goes smoothly, to fix your tool, to make some evolutions. It can be very time consuming, and you may spend more time fixing your tool than configuring your computer. It can be a fun project though, but it was not what I was looking for. Let's discuss the solution I've chosen. Ansible is a Python automation tool to provision and configure servers. It can be used to apply configuration on hundreds of distant servers, or what will be interesting for us, one local computer. Ansible has a notion of role and playbooks, which we'll talk about in the next slides, and it also has a huge community we can rely on. Whether you like it or hate it, Ansible uses a YAML syntax, which is quite easy to read. First, if we take a look at this file tree, we can see that the role folder contains different local roles to achieve related tasks, such as anything concerning my Git configurations or how to install the JetBrains toolbox. Then we can find the playbook directory, which contains one folder per computer. What's included in a playbook? It will run on a host, here localhost. We can find an array of tasks that contains different tasks. A task should be named after what it does, and we'll call a module with optional attributes. In this case, we can see that I call the debug module with the message attributes. Then we can see an array of roles that either come from a local role, such as my git config we've seen before, or from the Ansible community, such as the Docker role right here. The become flag on line 9 is used to perform super user related tasks. Let's see how to apply this configuration on my computer. First, we'll need to install the Python dependencies and the community related role. We can see that the only Python dependencies needed is Ansible itself and is defined in the requirements.txt file. Next, we need to use the Ansible Galaxy command provided by the Ansible package to install the community-related roles. To do so, we can declare a requirements.yaml file which contains every role we need. Our dependencies are installed. We are ready to go and can run Ansible to configure our computer. Ansible offers an Ansible playbook command to run a playbook with the playbook name as parameter. The dash key here is used to provide the superuser passwords to perform superuser related tasks when needed. If we take a look at the output Ansible provides, we can see it performs 2 tasks, but only one change. Ansible is idempotent, which means it won't retry a task if it does not need modification. In this example, my git config file already existed, so Ansible did nothing about it. However, it did not match what I was expecting, so Ansible changed the content of the file to match my need. This means that if you replay the same Ansible command twice, the second time no modification should occur. Now, let's see a few Ansible modules that can come in handy to configure our computer. The first one is the package module to install software. We give the module a list of the software we want using a variable, here containing 3 softwares. And Ansible will ensure these packages are installed on this computer. We can use a variable to install different software on your personal and professional laptop. To do so, one way to do it is to override the package to install variable at the playbook level right here. In this example, I don't need on my personal laptop VS Code, so I only install Vim and Firefox. Next, this role reproduces the behavior of stow by creating symlinks on a set of files to my home directory. We can see that I have a symlink role that contains a file folder which contains all my .files configuration. I then have a tasks that will loop over these files and for which we'll call the file module with the state attribute value to link. So it will create a symlink. I can now edit my .files as usual, since they are symlinked, and just have to review changes in my Git repository, commit, and push them. Sadly, symlinked are not always an option. You may have some files that requires dedicated configuration to be functional. A classic example is my Git configuration, where I have my name and email that is different on my personal and professional laptop. Thankfully, Ansible offers a templating engine using Jinja 2 to offer a templating system, so we can use it to template our files with loop, condition, variables, and so on. Here's the link to the documentation if you want to take a look on what you can achieve with this. Now, we sometimes need to copy secrets in a dedicated location on our computer, like a token value to authenticate against a private registry. If we take a look at this task, one could believe we put the plaintext versions of the secret files into our Git repository. However, we'll see that this is not the case, and we only store unencrypted versions of our secrets in the Git repository, and Ansible decrypted the secrets when needed. This is done with a dedicated tool, Ansible Vault. We'll see how to use it within our playbook. First, we'll need to create a vault where we will store our secrets or secret variables. Ansible will ask for a password, and you will have to remember it. To decrypt the data, we can use the view command to see the content of our files. And to use it within your playbook, we need to provide the ask vault pass, which will ask for the vault password as startup, and Ansible will decrypt your file when needed. As we saw before, Ansible is a combination of role and playbook and tasks, with custom variables. Therefore, to manage multiple computers, we just have to create a new playbook with needed roles and custom variables. To put it in a nutshell, Ansible has my back on all of my needs, with few constraints. I'm able to manage my .files and my installed softwares, and in an easy way using YAML syntax. I can also review changes quite easily, and adding a new software or a new configuration file doesn't take much time. I'm able to manage both my personal and professional computer with dedicated playbooks, reusing roles for most of my needs. I'm also able to handle secrets with the Vault system to store my secrets safely. If you need to do further configuration, I invite you to take a look at the documentation and existing roles and the Ansible community. There is probably a role that already exists that fits your needs, and you can reuse or contribute to it without having to start from scratch. To end this presentation, I'd like to point out that Ansible is not a silver bullet. It is powerful, and you will be able to do almost anything with it, but it comes with a little learning curves. It's still easier than building your own tool from scratch, and the knowledge of Ansible might prove useful for your future work. But let's be honest, if you only have one or two files to manage, Ansible is not the right tool, and you'll be fine with Tow. In the end, everyone will have their own solution, and I hope I gave you an overview of what you could potentially achieve. Here's the link to my own .files repository managed with Ansible if you want to take a look. And I'd like to thank you for your attention. You will find a QR code to the slide on the left. You can give some feedback on the right, and you can find ways to contact me through my website right here. Thank you. And I think I have like 40 seconds for questions, so I'll be available right after if you want to. I have a setup script which install Python dependencies and run Ansible right after.
So just clone
Exactly.
Can you do it on macOS and Windows?
macOS, yes. Windows, there is a Windows module available. On Mac and Linux, it will be okay. On Windows, maybe not as much module as on Linux, but you should be fine either way. Thank you.